Good morning, students. Welcome to class. This morning, we'll be looking at water under the objectives. I'm going to explain the types of hard water. We're going to explain the advantages and disadvantages of hard water. I'm going to explain the test for presence of water. And I'm going to discuss the treatment of water for household use. Now, we all know that water is so important for living. It's a universal solvent, and we have various sources of water, such as the rain, the well, river, lake, stream, tap, etc. Types of hard water. We have the temporarily hard water and the permanently hard water. Now I'm going to start with the temporarily hard water. This is caused by the presence of this substance in a sample of water. And this can be removed by boiling. By the time you boil, application of it is going to cause the decomposition of the substance. Also, it can be removed by the addition of slaked lime. The permanently hard water. This is caused by the presence of magnesium and calcium ions in the form of tetraosulfates or chlorides in a sample of water. And to treat this, you can add your washing soda, sodium hydroxide, or you can use the pegmatite and zeolite. These are ion exchange resins. There's a way we go about it to remove the permanently hard water. What are the advantages of hard water? The first one, it tastes better because it contains minerals in it. The second point, the minerals in it, for example, the calcium salt, is used by animals for the formation of strong bone and teeth. The third point, animals such as snails and crabs make use of this calcium present to build their shells. And lastly, it can be supplied in pipes made of lead without the fear of lead poisoning. What are the advantages, the disadvantages of hard water? The first one, it wastes soap a lot. If you're using hard water to wash, you need to apply large or much quantity of soap for it to foam easily. The second point, it causes fluorine of kettle. That's when you look at your kettle or your boiler, you have some white deposits beneath it. So that is called fluorine of kettle. And the last one, it cannot be used for dyeing and tanning because the presence of those minerals will interfere with the reaction. How do we test for the presence of water? The first thing that can be done, we can test with anhydrous copper 2 tetraosulfates. The original color of this salt is white. By the time it comes in contact with any substance that contains water, it is going to turn to blue. And the second substance that can be used to test for the presence of water is cobalt 2 chloride. The original color is blue. When it comes in contact with a substance that contains water, it is going to change to pink. And lastly, I'm going to talk briefly on the treatment of water for household use. Now, this is water coming in here from any source. When the water comes in, immediately it comes in, and the screen is going to act like a filter that's going to protect the solid waste from passing over to the next stage. For example, if we have plastics in a water body, by the time it's coming here, now the screen is going to tap the solid materials from going further. Now, at this stage, you have this container where lime is being introduced. Lime is being introduced there because it's going to act as a water softener. So if the sample of water coming in is hard water, introduction of lime is going to remove the hardness of the water. And thereafter, it's going to go to this basin here. In that basin here, you're going to have a coagulant introduced. For example, we can add alum. Now, the function of that is to accumulate or cause the coagulation of the fine particles into a larger size. And that is what we call floc. So the fine particles will now come together, it will coagulate and go to the bottom of the basin. Thereafter, it moves to the sedimentation basin, from the name sedimentation. So there's going to be division. The particles will be beneath and the pure sample of water will be above. Now from there, from what we can see here, you can see the dirty parts on top and you have your clean water here. Now at this point, this was the clean sample of water now. We move to this basin. At this point, remember we've removed the solid, the material, the solid pollutants, but we might still have some microorganisms present in that sample of water. So at this point, disinfection takes place. We make use of substances like chlorine, which is going to act on the microorganism present. Then, at that point, you have your pure sample of water, which will go to the storage tank, and thereafter, it will be distributed to different households. Join me in class for further discussion on this.